Hello class, let's look at molecules and compounds. Calculate the molecular mass of each of the following compounds. To do this question, we are going to use the periodic table. So let's do the part A, carbon monoxide. This molecule is made up of one carbon atom and one oxygen atom. So we are going to find the mass of carbon, which is 12.01, and the mass of oxygen, which is 16.00. We are going to add these two values together, and the molecular mass of carbon monoxide is 28.01. We do the same thing to phosphorus trifluoride. So you will notice it has one phosphorus atom and three fluorine atoms. So we are going to go to the periodic table and find the mass of phosphorus 30.97, then find the mass of fluorine, and we are going to multiply it by 3. So the answer is 87.97. And how do you do when you have a compound like this? Sodium sulfate. So this sulfate is a polyatomic anion. So we go to the periodic table and find the mass of sodium 22.99. We are going to multiply it by 2 because we have Na2. And we are going to find the mass of sulfur, which is 32.07, and then we are going to multiply 4 times the mass of oxygen. So your answer is 142.05. And we do the same thing, and you are going to find the mass of iron, which is 55.85, and then we are going to first do the NO3 and then multiply it by 2. So nitrogen is 14.01, and we are going to add 3 times 16, and then we are going to multiply this whole thing by 2. So your answer is 179.87. When you have a hydrated compound like this, you should know that this is a single compound. So you're going to find the mass of zinc, which is 65.38, and you're going to add 2 chlorines, 2 times 35.45. And you have 5 water molecules, and you are going to find the mass of water, which is 1.008 times 2 plus 16, and you have 5 of those, so you are going to multiply it by 5. Remember, when you see a dot like this, that means this is a hydrated compound and it is a single compound. So your answer is 226.36. Determine the charge of the metal in each of the following compounds. Let's look at the periodic table. The elements in group 1, 2, and 3 usually make cations with the charge equal to its group number. The exception is hydrogen. The elements in group 5, 6, and 7 makes anions with the charge equals to group number minus 8. And the elements in group 8 do not make ions. In the group 4, the charges can be plus 4 or minus 4. So your transition metals make variable charge compounds. The exceptions are silver and zinc. So let's go to part A, cobalt chloride. So this is a neutral compound. The charges of these two elements equal to 0. So we are going to find the charge of metal. So we are going to designate it as X. So chlorine is in group 7, which is minus 1, and we have 2 chlorine atoms. That means we are going to multiply it by 2, and then whole thing is equal to 0, and then you see that charge of cobalt is +2. Then we do part C, copper sulfide. So copper is the one we are going to find, and because we have two copper atoms, we are going to use it as 2x, and sulfur is in sixth group, and then it's going to be -2. So you will see that the copper charge is +1. In this case, we are going to designate X as the charge of platinum, and sulfate, we are going to use the polyatomic. This is a polyatomic anion, and the charge is -2. And you have two sulfate ions, that means -2 times 2, and the whole molecule is neutral, and we are going to equal the whole charges to 0. And you will see that the charge of the platinum is +4. So in this case, nitrogen has -3 charge, X -3 equals 0, and nickel has +3 charge. Chromium trioxide. So we are going to designate the charge of chromium as X and oxygen as -2 times 3, and the charge of the chromium is +6. Complete the following table and name the compounds. You can see the answers, and let's see how we got these answers. So lithium has +1 and iodide has -1. If we do the crossover method, the compound we are going to make is lithium iodide. So the next one, lithium is +1 and oxide has 2-. We are going to do the crossover method, and then we are going to end up with Li2O. So lithium nitride, lithium has +1, nitrogen has 3-. So when we do the crossover method, we are going to end up with Li3N. Ferrous, Fe2+ and iodine has 1-. So we do the crossover method, and the compound is FeI2. So in this case, ferrous has 2+ and oxygen also 2-. If we do crossover method, we are going to end up with Fe2O2, and we can simplify it as FeO. Iron has 2+ and nitrogen has 3-. So we are going to do the crossover method, and we are going to end up with Fe3N2. Aluminium is 3+ and iodine is -. So we are going to do the crossover method, and we are going to end up with Al(I3). So aluminium is 3+ and oxygen is 2-. So we do the crossover method again, aluminium 2O3. Aluminium is 3+ and nitrogen is 3-. So we are going to end up with Al3N3, and we are going to simplify it to Aln. Name each of the following compounds. Normally when we name compounds, the cation is simply the name of the element. If the anion is a monoatomic anion, we are going to add the suffix "ide". And there's exception when we name the metals with variable charges. Example as this one. So let's do part A. The cation is the name of the element nickel, and you are going to find the charge of the nickel as we discussed in the earlier slide, and you will see it's nickel 2, and you have a chloride, and you are going to add the "ide" suffix at the end. And also you will notice that this is a hydrated compound. When you have 6 water molecules, we called hexahydrate. So magnesium is not a variable charge metal. So we are going to call magnesium as the element magnesium. We have bromide, ide suffix, and then we have 4 water molecules, that means tetrahydrate. Calcium sulfate, again, this is not a variable charge metal, so we don't have to find the charge. We are going to write the cation as calcium, and this is a polyatomic anion. So you have to know how to name your polyatomic anions. This is sulfate, and you have 2 water molecules, that means dihydrate. Barium and the hydroxide, we end up with ide suffix, and we have 8 water molecules, that means this is barium hydroxide octahydrate. Write formulas for each of the following compounds. Let's go to part A, disulfur decafluoride. So the naming covalent compounds is the easiest because you have given your prefixes. Disulfur means you have 2 sulfur, and decafluoride means you have 10 fluorine atoms. Part B, ammonium permanganate. So you have to know your polyatomic cations and polyatomic anions. So ammonium is NH4 plus 1, permanganate is MnO4 minus 1. So if we use the crossover method, we are going to end up with NH4 MnO4. Chromium 6 perchlorate. So when it comes to naming compounds with variable charge metals, and it's going to be a little trickier than naming the covalent molecules. So chromium is 6 plus, it's given, and we know perchlorate is a polyatomic anion with -1 charge. So we are going to use the crossover method. We are going to end up with chromium Cl4 times 6. Sodium carbonate decahydrate. Sodium carbonate is sodium plus, and your carbonate is 2 minus, and you are going to end up with Na2CO3 dot decahydrate means 10H2O. Tetraselenium tetranitride. The covalent compounds are the easiest one to write down. So tetra means 4 seleniums, and tetranitride means again 4 nitrogens. Triphosphorus pentaiodide. Tri means 3, penta means 5, P3I5. If there was a nonmetal, remember this is a nonmetal called Dr. Spokium, and it had the chemical symbol Sp, what would be the name of the compound SpO2? So remember this is a nonmetal. So when you look at the answers, the first thing you notice are these are variable charge metals. So this cannot be your answer. So now we are going to end up with choices between A and E. So when you name a covalent compound, you always have to use your prefixes. So in this one, it doesn't have the prefix for oxide. So this is going to not your answer. And that means E. Your answer to this question is Dr. Spokium dioxide. So this is the end of this session, and please let me know if you have more questions. Thank you.